So again, with the application of your circular functions, you always want to remember cosine is the easier function to write, okay? When you're trying to figure out your amplitude, and this is in the sense of writing the equation. So when you want to try to find your amplitude, which is the A in the equation, you want to take your max and your minimum values, add them together, divide by 2. Your vertical shift, you take your max and you subtract your min, divide by 2. Your period is 2 times the distance between your max and your min, or however long it takes for the problem to complete one cycle. Okay, that really depends on what type of problem you're dealing with. Like if you're dealing with a Ferris wheel problem, it talks about a person gets on and rides it all the way around, and it takes them 20 minutes to go around or something like that, then 20 would be your period, because that's how long it takes them to go one full cycle, one time around the Ferris wheel. However, say they give you a graph that models a wave pattern, and they don't give you anything else in the description, well, then in that case, you would figure out where the max is located, where the min is located, looking at your x values, and then you would double it to get your period. So it kind of really just depends on the problem that you're given, how you'll determine the period. Okay, and remember the period is always equal to 2 pi over b, so then you would have to set that answer equal to 2 pi over b to find b, which goes in your equation. Lastly, your horizontal shift is how long it takes the graph to reach its maximum height. That's why we always use cosine. It's easier to figure out the horizontal distance to your maximum height, and we all know that cosine starts at 0, 1 on a normal graph, so finding the maximum is the easiest way to do it. So, we're going to look at 2 examples. You don't necessarily have to write them down. I am recording this video so you guys can reference it as you need to, but we are going to work it out together. Okay? So, let's take a look at that example. A Ferris wheel at an amusement park reaches a maximum height of 46 meters and a minimum height of 1 meter. It takes 20 minutes for the wheel to make one full rotation. If a child gets on the Ferris wheel when t equals 0, how long or how high will he be after riding for 10 minutes? How do we figure that out? First, do we need to set up our equation to answer part A?
No, you just put 46.
It's half of what?
So it's 46.
It'll be 46.
Yeah.
Yeah, it'll be 46.
So you'll be at the top.
What is this? All right, because if we think about it, we have this Ferris wheel, okay, that is a little bit off the ground, okay. The base of that is 1 meter, and then its maximum height is a full 46 meters. All right, so after 10 minutes, you've gone halfway because the person gets on right here, and when they ride it, they've gone half the distance. or half the time distance, but it's still at the top. Now we're going to write a cosine function to model the height of the child t minutes after boarding the Ferris wheel. So that your equation is set up as y equals a cosine. Do you want to pull the b out or you want to put it in?
Put it in, because I don't think they're going to do it.
It's up to you. It's a little easier to leave it out because remember, when it's already pulled out, C is your phase shift. Okay, so if we have a phase shift, all we have to do is literally put that number in, and if we wanted to, we could distribute the B over after we find it. So how do we find A?
Max plus min divided by 2.
Max plus min divided by 2. Okay, what's your maximum height?
46.
And so we add that to our minimum height?
1.
1.
47.
And we divide by 2. So max is 46. Minus 1. So A is what again? I heard that. 23.5. Cosine. Now we have to find B. For B, we need our period. What's our period?
20 minutes.
20 minutes. So in order to find B, we have to take our period and
So equal 2 pi of b equals 20. Multiply by b divided by 20.
questions up to here.
For the amplitude, I get confused because wouldn't it be like
Yeah, that's what
half of the circle, so it'd be 45 over 2, so it'd be half times 1 over 2.
It would be half the distance between your max and your min. And since your maximum height of your Ferris wheel is 46, the Ferris wheel reaches a maximum height in 46 meters.
No, but don't you have to incorporate that? It's still 1 meter off the ground.
It is the one we still have to incorporate that. It's just a question of is the 46 meters in relationship to the ground or just the wheel itself?
Feet from the ground. Yeah.
And if 46 is from the ground, that's so then it's 45 because it's just the ground, so at the radius of that.
It will be max plus min for your amplitude, not max minus. You're finding vertical shift. You do the subtraction. Yes, remember max plus min divided by 2 is your amplitude. And that's the easiest way I think about it. Think about the original sine or cosine function, right? The max is 1, the min is negative 1. We know the amplitude has to be 1. So do we add or do we subtract the 2 to get your maximum? Alright, so we gotta go back and fix this. It's backwards.
I don't think we told that on the last one, too.
This one's a plus, and this one's a minus. That was my mistake. That was a minus, that's a plus. Your amplitude represents how high it is, so in order 1 minus and negative 1 gives you 2 divided by 2. So yeah. Sorry, it's max minus min is your amplitude, and vertical shift is max plus min divided by 2.
Got it now, right?
So then to adjust this, what's our A?
22.5.
22.5.
You can't add another line.
So B is still pi over 10, x minus, pi over 10.
C.
Oh, C, okay. C would be 10, because that is how long it would take you to reach the maximum height, which represents your phase shift. And lastly, you would have your D, which is 23.5 max plus min divided by 2. Questions?
There period, right? So if it gives you a time it takes, you set it equal to 2 pi over b.
Yes, because that is how long it takes to reach the full, and that is. So there's
It doesn't you find the difference between the axes.
yes. So how high is the child if he has been riding for 3 minutes? How do you determine that? Plug in 3 for x. So go ahead and do that. You need your calculator for this. And you want to make sure that you're in what mode? Radian. You want to be in radian for this. So you're going to plug in 3. Into that equation you just wrote to get your height. Alright, so what you guys get? So 10.3 meters. Okay? So not too far, because think about it. If it takes 10 minutes to bring it to the top, that means it takes 5 minutes to make it to about here, so you would have to be pretty low. Okay? And then it says for what length of time will the child be higher than 40 meters? How do we figure that out? You said y equal to 40, and use your calculator here. Make it easier on yourself.
Oh, with the graph.
With the graph. You type that equation into your graph, adjust your window so that way you can actually see 40. You already know what your max is. What's your maximum height?
46.
46. What's your minimum height?
1.
Is 1 for the graph, but you could leave it at 0 and you'll see that it won't even touch 0. And we're talking about time, so if I wanted to, I could actually change this to 0. And 20 was my period, wasn't it? So I should see one complete cycle when I press graph, if I typed it in correct. And there's the graph that models the Ferris wheel.
Or you typed in that.
No, I typed in when you guys were working on press.
Oh, I'm about to say.
And then I also want to plug in 40 to make this even easier. Excuse me. And we're trying to see what length of time will the child be higher than 40 meters. So we need to do what? Find the intersection of this point here and this one here, and then subtract them, okay? You guys go ahead and do that.
We don't round.
Alright, so you find your intersection points. What was the first intersection point? Bless you.
7.62036512.
And then what was the other one?
12.379635.
So you subtract them and you end up getting 4 points.
4.59.
And that's seconds, minutes, minutes. Okay? These are about as hard as they get when you actually have to write your own equation versus when an equation is actually given to you, you're asked to basically figure out different pieces of information. So there you go. That's pretty much applications. Okay. And the reason why I'm only doing one example is because, in all honesty, when I went back through to try to find an example, I couldn't find one that we had not done already. So you guys have a lot of examples in your notes. Hopefully you haven't lost them. Maybe somebody can pass them over to Brian since he wasn't here last year. Go back through and look at those. Okay. I do have some prompts I want you guys to work on for homework. And I do want those due by